Hey everyone, Mr. Wagner here with Geometry Lesson 4.5. Got a special guest here that really wants to introduce this lesson to you, so without further ado, I give you Fire Marshal Bill.
Hey kids, let me show you something. These are the words you should understand for today's lesson. This is the vocabulary. Let's move on and figure out, okay, these are the examples that you should use, or you should use some extra examples in your book to help you out with today's lesson. Okay.
Thank you, Fire Marshal Bill. Wow. Okay, yes, thank you. Oh, good. He's gone. All right. Anyways, if you can, let's write this down. So we're going to be learning about 4.5 using congruent triangles. If you can, let's finish this up here. If you can prove two triangles. It's not a very pretty triangles symbol. There we go. If you can prove two triangles are congruent, then you can prove that all corresponding parts are congruent to or as well. So this lesson, more than any we've had so far, is really going to be a review lesson. If I look back at 4.2, so I've got 4.2, 4.3, 4.4 all ready to show you up here. This is looking back now. So congruent figures, we knew they had exactly the same size and shape. If we had congruent triangles, we knew that all 6 parts had to match up. But then in 4.3, we learned some different shortcuts. We learned about side, 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 and we learned about side, angle, side. And then in 4.4, we learned the rest. We learned angle, side, angle, and angle, angle, side, at least the rest for us so far. There may be more. We're going to explore that more in future lessons. But for right now, this is what we've got. And so if we can prove congruent triangles, either by proving all parts are congruent or by using one of those shortcuts, we can prove that their corresponding parts are congruent as well. So make sure you have that written down. And then write this kind of big. I did not lift my pen. Why does it keep doing that? CPCTC. This stands for something pretty important for us. This is the only real new thing in this lesson. Everything else is going to be stuff we've done before. What does CPCTC stand for? I know what you're probably thinking. This is probably what you're thinking. It stands for, Mr. Wagner, of course, it stands for the Cecil Park Clay Target Club, which is a park right here in New South Wales, Australia. I know that's what you were thinking. Yeah, right there, suburb of Sydney, Australia. We can even zoom out on that map there. There's New South Wales. There you are. I know that's what you were thinking, but I'm sorry, that's not what I was looking for. What I was looking for is this. So this actually stands for us in geometry at least, corresponding parts of congruent triangles are congruent. That's what that stands for. Unless you live in New South Wales, Australia, I guess. Then you just get confused, because you could say they speak English over there. They could say CPCTC stands for this. So here's what I'm talking about. That's where that comes from. The O and the A, usually those small words, those insignificant words we sometimes leave out of the acronym. So CPCTC stands for corresponding parts of congruent triangles are congruent. Got to know that for this lesson here. So I'm going to circle that. That's the only real new thing, the only non-review type thing in this whole lesson. Very important to know that acronym. We're going to use that a lot in this lesson and in the future from here, but especially this lesson. So let's start off with this. Have your different colors out. Be ready to use some different colors. And however, to start, let's just do this in pencil. Everything you see here, put in pencil to start. So I'm going to have parallel sides right there and right there. I'm going to have parallel sides right here and right here. Got to use different number of arrows to say that this is parallel to this, and then these are not parallel to these ones, but they are parallel with respect to each other. And I'm also going to give the vertices of these labels T-O-N down here and Y right here. Okay, so Tony, that is the name I'm going with here to start. So let's say for the given, we'll just write C below. We'll fill that in the proof. We're going to be going through some proofs here as this lesson progresses. So it's a good review of proofs and how that all works out too. So again, a great review lesson here. Nothing really new except for that CPCTC thing. So here we have this being what I want to prove in the end. Angle OTY is congruent to angle YNO. Angle OTY to YNO. So let's make our two columns. We're going to do the two-column proof format. Remember, there's also flow proofs and there's also paragraph proofs, but we're just going to go with the basic two-column proof for us that we've been doing. We're going to stick with that. That will be a good way to think about this lesson here. I was starting to freak out for a second. My pictures over here disappeared, but it's just because I went over here and this popped off of the side. Okay, so I'll talk about those pictures at the end. Here's statements, here's reasons. Let's start filling it in. So step one, what do we start with? The given. Write down given. What is given? So what's given in the picture, first of all? What did I tell you was true in the picture? Let's start with that. I said that TO, segment TO, was parallel to segment NY. And I also said, you can see up here, that TY is parallel to ON. TY parallel to ON. Anything else I gave you in the picture? No. Anything else I'm going to tell you is given? No, that's it. Okay, so just from there, you think it's possible to prove this? Well, you might be thinking, yeah, because you wouldn't have done it as an example, right, Mr. Wagner? Right. Okay, it is possible in this case. I'm not going to try to trick you here on this one. Maybe in the future, though, but not on this one. So is this possible to prove? Well, let's see. What do I see in here? What can I prove is true? Take out your different color. Take it out right now. Different color. Different color. Don't use pencil for this. Use a different color. Okay. You got your different color? You ready? Here we go. Alright, so we've got this. I could say that's true. Well, what are you doing? Why is that true? What's true? Oh, okay, I got you. So I'm trying to prove, that's my first step here. I want to try to prove that these triangles are congruent. And then if I can prove the triangles here are congruent, then I could say that their corresponding parts match up. OTY is this angle right here, and then YNO is this angle right here. Those seem to be corresponding to me. And so if I could prove the triangles are congruent, then I could say their parts match up, the CPCTC. So this is true. That's the same segment in both triangles. So why can I say that's true? Well, we saw this in our previous lesson. In 4.4 we saw that we used, not in that one, but in this one, here it is. We have the same segment being present in both. Here's the reflexive property. It's the same sort of idea here. So this gets used again in this lesson. OY is congruent to OY by the reflexive property. You could say the reflexive property of congruence in this case, because it is a congruent symbol right there. We can just leave it at that. Okay, so I've got side, but I am supposed to have a bunch of different things. I'm supposed to have one of four things basically to prove. So do I have one of these four? This is from 4.4 still, so this isn't something new to write down, but do I have one of these four things? Well, not yet. I just have a side. If I had some angles in there, maybe. If I had these two sides and these two sides matching up, maybe. Because they're parallel doesn't mean that the sides are congruent necessarily. Could be, but we don't know that yet. But I have, okay, this should be ringing a bell. Alright, you have parallel lines. You have a transversal. What about this angle right here and this angle right here? Why can I put an arc mark there and there? with respect to this transversal and these two parallel sides, that would be the alternate interior angles. That would be alternate interior angles. So let's put that down. I'm going to have to say angle TOY. I'll go with angle TOY is congruent to angle. So TOY matches up with NYO. NYO. This is true by alternate interior angles. So this one to me, the OY congruent to OY, that was most obvious first to me. And then this was next most obvious to me. And I look at this, and do I see anything else? Well, I look at that, and I see that this angle here, let's get out my red here again. I see that this angle right here is congruent to this angle down here for the same reason. We have this side being parallel, and then this now is my transversal. That would tell me that that and that are congruent. The same reason, again, that's alternate interior angles with respect to this transversal. So I could say that angle TYO now is congruent. So here's TYO is congruent to NOY. NOY. And again, that's alternate interior angles, so I'll just leave that right there. That's step 3. So you can say this and this by alternate interior angles. Okay, so now what? Can I say that the angles match up now? Well, almost, not quite yet, but I am almost there. I just need to say first that the triangles are congruent, which I can say now. I can say that triangle TOY is congruent to triangle. So TOY matches up in the same order. I want to make that congruent statement correct. So TOY, I would have to go to the 1 arc mark, then the 2 arc mark. So NYO would be the appropriate congruent statement. NYO. Why is that true? You have an angle and a side and an angle matching up with an angle, included side and an angle. So it's the angle, included side, and angle in both triangles. That's ASA, angle, side, angle. Now that you have the triangles being congruent, go back here, this is what we said. Prove 2 triangles are congruent. We just did that. Then what can we say? You can prove that all corresponding parts are congruent as well. Now I can use this CPCTC new idea, and I can say that this is true. Angle OTY is congruent to angle YNO. So I could, now that I said that, I could put congruent marks here and here. I'm going to leave those out though. We're just saying that these, now that would be true based on this. Based on CPCTC. If you wanted to write out this whole thing, corresponding parts of congruent triangles are congruent, if you wanted to write that out, be my guest, but you can just write out CPCTC and I'll know exactly what you're talking about. Alright, so let's move on to a second example. Alright, here we go. Oh, whoa, hold on. What am I forgetting? I'm forgetting to show you the picture. So, some famous Tonys that I know of at least. This guy, you may not know. If you're a gamer, you may have played Tony Hawk's skateboard type games before. This guy was really good, still, as far as I know, a really good skateboarder. And famous Tony the Tiger. If you're a breakfast cereal fan, you probably have had some Frosted Flakes in your life. What's up, Tony? So, here's our next one. Let's put this as an A, L, I, C down here, and E. So Alice. Maybe you can think of some famous Alices. You might even be able to tell the corner of that picture who I'm going to pull up for that one. So let's just write down. Nope, I don't want to write that yet. Given first. There you go, Mr. Wagner. Come on now. Given. What is going to be given to us? Well, again, here I'm going to say C below. So this one we'll just save ourselves some writing. We won't write it twice. But to prove, here's what I want to prove. This is my last step for this one. I want to prove that I is the midpoint of segment AC. I'm going to try to prove that that is true. I is the midpoint of segment AC. So let's see if there's anything else I was going to give you being true in the picture. There sure is. I'm going to tell you that this side is parallel to this side. And I'm going to tell you that this side is also congruent to this side. So I can have both markings there on the same segment. They can be parallel, they can also be congruent to each other. And from there I'm going to stop it there and say that's all I'm going to give you. We may be able to prove some other stuff based on what we have there in the picture, but for right now, nothing else. So let's make our two columns. Let's put an S and R, statements and reasons here, and let's start working. So we have number one, step one is given. What's given? So let's check it out in the picture here. What did I give you being true? Well, I can see that segment AL is parallel to segment CE or EC. It wouldn't really matter, the order of the letters. You could also say that segment AL is congruent to segment EC. Those are both given in the picture. Anything else that's given here that I told you up here? No. So we gotta just start with that. Now, again, proofs. What can you logically deduce, either from what's given or what you can see in the picture? What has to be true from there? So I'm going to start with what I feel like is most obvious. Looking at that, this is what I feel like is most obvious that I can see. I would say, well, get right there and there. That's got to be true. Why does it have to be true? What kinds of angles are those? Those are, again, use a different color here. As we add things in, use different color. If you use black, it's not going to make sense when you look at it later. So use different colors as we add things in here. I could say that I can't just say angle I, there's different angles here, so I could say angle AL, AIL, is congruent to angle AIL would match up in the same way. I would go with CIE here. If you said EIC, that would also work. But AL and CIE, what kinds of angles are those? Those are vertical angles. So you could say vertical angles, or you could say vertical angles theorem. Theorem is a little better, but if you just said vertical angles, that works for me too. So vertical angles is what I have there. So now I've got a side. I've got this angle here, but I need one more. I need one of these things here. I need one of these four. Or I could get all three sides, but that doesn't seem to be where I'm going with this one. It seems like it's going to either be 2, 3, or 4, because I got an angle in there. So can I prove this side or this side or this side or this side going to match up? Not seeing anything. If I was told that it was the midpoint right here, if I was the midpoint, then we could say that. But that's what we're trying to prove. We're trying to prove that it's the midpoint. So I can't say that's congruent to that. I can't say this is congruent to this. But hey, here's those parallel lines again. If you see parallel lines, you should always be asking yourself with these kinds of questions, can I prove alternate interior angles are congruent? So let's take a look. Let's check it out. Do I have alternate interior angles? Here's a parallel line. Here's a parallel line. Here's a transversal. Could I say that this is congruent to this based on that? Yes, I could. So alternate interior angles with this one and this one with respect to this transversal. Let's write that down. Here we have, I could keep it simple here. There's only one angle at L, so angle L is congruent to angle E, and this would be true by alternate interior angles. Could I also say that angle A is congruent to angle C? If I look at the picture, yeah, that's another alternate interior angle. But do I need to say that? Look at the picture again. I've got angle, side already. So why say something extra when I'm already done basically with what I need to prove that the triangles are congruent? Might as well stop there and now say that the triangles match up. So angle or triangle AIL is congruent to triangle. So A to I to L, we're going to go from no arc marks to 1 to 2. We've got to keep that in the same order. So no arc marks to 1 to 2 to C, I, E. So the way I wrote it up here was the correct congruence, corresponding congruence statement. The parts, they match up like that. So this would be, why is that true? You have angle, non-included side. Angle, non-included side. So you'd say angle, side right there. Okay, so I'm still not seeing where you're going with this, Mr. Wagner. Oh, look here, just a second. AC, now I can say that this would be congruent to this. I could put basically 2 marks there and 2 marks there. Why don't I do some stuff in yellow? This stuff in yellow I don't want you to include on your notes, but I do want you to just make a note of it here. So in this one I said that this and this were the same. I'll put 3 marks there because of corresponding parts of congruent triangles being congruent. So I could say that those matched up. And this one I could now say that, don't write this down again, but I could say that this is true based on what I just did. So because of that, again, don't write the yellow stuff down. This is just kind of to be thinking about. Now I can say here that AI, segment AI, is congruent to segment, not A, but 2 more, there we go, is congruent to segment IC. And that would be true because they're corresponding parts of congruent triangles. So corresponding parts of congruent triangles are congruent. CPCTC. And now, because of that, because this and this are the same, basically that is how you define a midpoint. A midpoint will divide a segment into 2 equal or congruent parts. So this is kind of like, remember, definitions can go frontwards or backwards. You can say that if this is a midpoint, then these are congruent. You can say that if these are congruent, then that's the midpoint. So I can say that now I is the midpoint of segment AC, and I already gave you a big hint there. I said it was a definition, so the definition of midpoint would tell us that that is true. And some famous Alice's. I think it's a little strange that a guy is named Alice. That didn't used to be this guy's name, but that is Alice Cooper right there. He's a famous musician, and Alice in Wonderland, probably the most famous Alice that I can think of. I still haven't seen the new Johnny Depp Alice movie. Is it worth seeing? You can tell me in class. You can let me know if it's a worthwhile movie to go see. But Alice in Wonderland, another Alice there. So let's finish up here. Let's do one more example to kind of review things, hopefully very well, from previous lessons and even chapters, and also see some new things here. The one new thing here, the CPCTC. We're thinking we're probably going to use that in this one. I could put, I'm going to go with Jose here. I could put a little accent there. That's what it should have if we're using Spanish way, but I'm going to leave that out just so we don't get confused and think it's some sort of new mathematical symbol down here. So Jose is what I'm going with for this last one. And here's what's given. And we'll do the same sort of thing here. Let's not write it twice. Sometimes mathematicians are lazy. Being lazy in math is a good thing if you still have all the information you need. If you're just using symbols and shorthand and things like that, no problem with that as long as that is allowed and that's acceptable. That's why we use symbols for a lot of stuff. That's why I'd rather write CPCTC rather than corresponding parts of congruent triangles are congruent. Not that I'm necessarily lazy, I wouldn't say that, but I would say that I just don't want to do more work than I really need to. If something shorter gets the same job done, might as well do that. So let's make now our 2 columns again. So given and what's to prove. Here's my 2 columns. And these are going to be my statements here and my reasons here. And was I going to give you anything else in the picture? Yes, I was. One more thing. So this and this, those 2 segments are congruent to each other. So let's start off with what's given. So I'm going to look at the picture. I can clearly see that OS is congruent to ES in that picture. And then there's one other thing that's not in the picture that I am going to tell you is true. I'm also going to tell you that this is true, that segment JS bisects angle OSE. I'm going to tell you that that is true as well. Now, why would this be true? That is given. All right. And then step 2. So take what you got there and think about, well, at least to you, what's most obvious. To me, what's most obvious, since I just said that it bisected that, let's not forget about that, but let's take care of that right now. So JS right here bisects OSE. So what would that mean about this angle right here and this angle right here? They would have to be the same. And so let's write that in. That angle, we've got to use 3 letters on this one because there's multiple angles coming out of S there. So angle OSJ would be congruent to angle, I could say ESJ. And why would that be true? Well, we talked about it bisecting. That's how we define a bisector, and this is an angle bisector. It's cutting an angle in half. So definition of angle bisector. Alright, so let's do step 3. What else do you see in the picture that hopefully is pretty obvious that both triangles can have in common, or both triangles will have congruent one to the other? Well, I got a side here, I've got an angle. I can't prove the angles here are congruent. I can't prove, I didn't say that it bisected angle OJE, but I do see that they have this side in common. So they have side JS in common. So what can I say? Well, here it is again, and it shows up a lot in this chapter. JS is congruent to itself. That's the reflexive property right there. So the reflexive property gets used once again. It's not feeling so left out anymore. The transitive property sure was dominating the reflexive symmetric transitive usage before, but reflexive property getting used a bit more. It feels better about itself now. Higher self-esteem for the reflexive property than it used to have. So JS, congruent to JS. Now do I have what I need to prove triangles are congruent? I see OSE, you got one side, an angle, and a side. This is side, included angle on the side. I've got from E to S to J, I've got this side, this included angle on the side. So this looks like to me, yes, I can prove that the triangles are congruent. I would say triangle, the order of the first way you say it doesn't really matter, OSJ, but then this has got to match up. That congruent statement has to be correct. They have to be corresponding to each other. So OSJ, or OJS, sorry, is going to match up with EJS in that way in the other triangle. So EJS. Why would this be true? Again, we said side, included angle, and side. So this is side, angle, side. From there, we just proved the triangles were congruent. Now we're trying to say that these corresponding parts match up. So this is where I take out my yellow. I just tell you to listen on this one. And I could say 1, 2, 3, 1, 2, 3. I could say now that those sides matched up, because I have proved the triangles are congruent, these corresponding parts have to match up. So we're there. We are all set with this one. EJ is congruent to OJ because they are corresponding parts of congruent triangles being congruent. So CPCTC. And who do I got over here for this last one? If you're a baseball fan, there's a couple of really good baseball players right now that are playing in the majors that have the name Jose. Here's Jose Reyes, used to play for the Mets, currently playing for the Marlins as of the recording of this video. And then here is Jose Bautista. He was a home run champ for a couple years in the majors. A couple of very good players playing in the majors named Jose. I hope that helped you. Hopefully this was a very good review lesson for you, not only of proofs, but of things we've been learning, of those congruent statements for triangles, these 4 things so far, and also a good review of things being parallel with parallel lines, remembering that alternate interior angles match up. Lots of great review stuff, even vertical angles showing up here, and what midpoints are, what angle bisectors are, all kinds of stuff getting reviewed in this lesson. If you have any questions on the lesson, please let me know when we return to class. And no, Fire Marshal Bill, I'm not going to let you talk anymore. Sorry, you scared the kids. This will have to do. Go away, go away.